Hi, this is Adrian from Live to Learn Academy, and today we're going to be going over lesson 6.5, exploring graphs of reciprocal trigonomic functions. So let's look at the primary trigonomic functions. This is what we did in the last unit. We had sine x, cos x, and tan x. Now each of these functions, guys, has a reciprocal. And remember, a reciprocal is just 1 over sine x, 1 over cos x, and 1 over tan x. But we're not going to call it this. This actually has a name. And you guys might seen this in grade 11. It comes again in grade 12 because we do it in radians. But 1 over sine x is called cosecant x. So this is called cosecant. 1 over cos x is called secant x. And then 1 over tan x is called cotangent x. So these are the names for the reciprocal functions. Mind you, these are reciprocal trig functions. Now, it's one thing to know what these reciprocal trig functions are. It's another thing to actually graph them. So we're going to graph each of these things one by one. So first, we're going to go through the cosecant x graph. And this should be pretty straightforward. So we know sine, right? Sine looks like 0, pi over 2, pi, 3 pi over 2, and 2 pi. And we know the sine graph goes from 1 to -1. So remember, this is just sine. And I'm showing you the cosecant graph after drawing the sine graph so you understand how they're related. So this is a sine graph. The cosecant graph actually has asymptotes at the 0. So this is important. It has vertical asymptotes at the zeros. Okay, so let's look at where the zeros are on our sine graph. These are where the zeros are. And then our vertical asymptotes are going to be right at the zeros. Perfect. And then the next thing is it also has parabolas at the max and mins. So let's look at where our max and min are. Our max is here, our min is here. We are actually going to have parabolas that come here and go like this. So they're parabolas that hug the vertical asymptotes, but the vertex actually is at the max and the min. So this red graph is actually what our cosecant x graph is. Now there's a couple key features with the cosecant x graph that we want to know, right? So the first key feature is this. So I'm actually going to take this and put this here because this is the first key feature. Has vertical asymptotes at the 0 and parabolas at the max and the min. But the second key feature is we want to know the domain. So the domain is x is an element of the real where x does not equal any of the vertical asymptotes. And that's pretty straightforward. X cannot equal any of the vertical asymptotes. The range, however, is y is an element of the real where y has to be, the absolute value of y has to be greater than or equal to 1, right? Because at 1, it's everything above it, and at -1, it's everything below it. So some people might say the absolute value has to be greater than 1, or in some cases you may be able to say y must be greater than or equal to 1, and it also must be less than or equal to -1. So you can write it either way. Most textbooks you'll see them say the absolute value, but writing it like this is the exact same thing. So that's what we have for cosecant x. Now let's look at secant x. So remember, secant x is the reciprocal of cos x. So let's first draw out that. Let's draw out what cos x looks like. So we know cos x looks like this. And cos x, obviously, we start up here. And we go like that. So that's cos x, right? Secant x follows the exact same rule where the zeros are the vertical asymptotes. So we're going to draw vertical asymptotes at the zeros. And at the max and mins, we're going to do the exact same thing. We're going to draw our parabolas. Now, obviously, these guys will continue on the side as we keep going. So, guys, for secant x, it's literally the exact same thing as cosecant x. So, the rules, let's look at those key features again. The key features, I'll actually write it here. The key features of this graph, you're going to have the vertical asymptotes at the zeros and parabolas at the max and min. But the domain and range is just going to be slightly different. The domain, actually, the domain isn't really different. It's going to be x's element of the real, where x cannot equal the vertical asymptotes, right? And the range is y is an element of the real, where y has, the absolute value of y has to be greater than or equal to 1. Or we can say y is greater than or equal to 1 and y is less than or equal to -1. So we can say it like that. Now I want to go back to this domain and range because in the cosecant x graph, the vertical asymptotes are every n pi. If you look at it, every value of pi are going to be our vertical asymptotes because it's counting by pi. Because it starts at 0, goes to pi, then to 2 pi, then to 3 pi, then to 4 pi. So the vertical asymptotes will be every n pi. But over here, with the secant x graph, right? Every vertical asymptote is going to be pi over 2 plus pi, right? So the way the textbooks want to write it is they're actually going to write it as 2n minus 1 pi over 2, right? 2n minus 1 pi over 2. And all that means is that the vertical asymptote is every pi over 2. So pi over 2 plus pi will give me 3 pi over 2, plus pi will give me 5 pi over 2, plus pi will give me something else. But the reason why it's 2n minus 1 is because we're starting at the pi over 2. Versus at the other one, we're starting at the 0. So n pi would just work just fine. So that's the secant x graph. Okay, let's go into the cotangent x graph. Now, cotangent x, remember, is a little bit different from our traditional secant x and cosecant x. So let's first draw the tangent function. So we know the tangent function is going to be negative pi over 2, negative 3 pi over 2, pi over 2, and 3 pi over 2. So in the tangent function, the function actually looks like, a pi over 2 and negative pi over 2. We have the vertical asymptotes. And then what we got going on in the middle is we have what's going on in the middle is we have this swivel thing happening. So this is how our tangent function looks like. Now, with the cotangent function, it looks slightly different. So the rule is at the vertical asymptotes, those are going to be where the new swivels are. And at the zeros, those are going to be where the vertical asymptotes are. So I just want to show you the comparison because this function right here is actually your tangent function. You're going to see the difference right here. When we look at cotangent, you see how on the tangent function, the zeros were at 3 pi over 2, 0, and negative 3 pi over 2. In that case, those are going to be the actual new zeros. So let's look at it from this angle. So you have 0. So you're going to have a vertical asymptote over here. Your other vertical asymptote is actually going to be at pi and negative pi. So you're going to have a vertical asymptote here and a vertical asymptote here. And then your other asymptote is going to be at 2 pi and negative 2 pi. So these are where your vertical asymptotes are going to be. Now, these are your vertical asymptotes, but how does the function actually look like? So you see over here, and I kind of made a mistake over here. So this pi over 2 right here and the negative pi over 2, that's actually where our swivels are going to start happening. So at pi over 2 and negative pi over 2 is where our swivel is going to happen. And our swivels are actually going to go the opposite way. And then at 3 pi over 2, the swivels are going to come the opposite way. So you see how they look similar, but they're slightly different. So one thing, so let's look at the key features of this graph. So the first key feature is that where tan x equals 0, cotangent x has vertical asymptotes, right? So where tan x equals 0, the vertical asymptotes are at the points where tan x equals 0. The second thing we need to know is that cotangent x has zeros where tan x has vertical asymptotes, right? So cotangent x has zeros where tan x has vertical asymptotes. Where tan x is zeros, cotangent x has vertical asymptotes. So this is a little like tongue twister, right? The third thing is cotangent x and tan x both have the same period. This is important to know. When it comes to cotangent x, this right here is the period. Sorry, tan x is pi. But over here, all of these guys are also pi. So they have the same period. And let's look at the domain and range. The domain of cotangent x is x is an element of the real where x does not equal the vertical asymptotes, and the vertical asymptotes are happening at n pi because it's 0, pi, 2 pi, etc. And the range is just y is an element of the real, right? Because y is going to equal all real numbers, because if you look at this graph, it's going all the way from the top and all the way to the bottom. And it's just going on forever and ever and ever. So that's why it's y is an element of the real. So guys, when it comes to the secant, cosecant, and secant x, those are pretty straightforward. It's really just the cotangent x where most students mess up. So some key features, you know, the tan x goes from left to right. The cotangent x goes from right to left, right? In terms of how the swivel looks like. This is important to know. And then where the asymptotes are slightly shifted over depending on what's a 0 and what's a vertical asymptote from the tan x graph. So I hope this video meant a lot to you guys. If you found this video helpful in understanding reciprocal trig functions, please drop a thumbs up. It really helps the channel. If you're somebody who needs tutoring, you know, feel free to go click the link in our description, and we'd love to get you in touch with our tutoring team. But without further ado, I'll see you guys in the next video.